Assalamu alaikum. In the last video, we discussed the errors involved in the addition, subtraction, and multiplication of two quantities. In this video, we will discuss the errors involved in the division of two quantities, and also we will discuss the errors involved in the power of a given quantity. Let's do it. I'll start with the errors in the division of two quantities. For this, I select two quantities, quantity A and quantity B. Here, the measured value of A, measured value of A is found to be A plus or minus delta A. Here, delta A is the absolute error in the measurement of A. What is absolute error? Absolute error is nothing but the magnitude of the difference between true value and the measured value. Okay. So here, next the measured value of B is taken as B plus or minus delta B. Here, delta B is the absolute error in the measurement of B. Okay. Then I consider the division of two quantities as 0. I'm saying Z. Consider the division as Z, which is nothing but A upon B. Okay. Now, here I include a Z with its error, absolute error, which is delta Z. Then I do the same thing with the A and B. A plus or minus delta A divided by the measured value of B, which is a B plus or minus a delta B. Okay. Then after that, I take A outside. It is taken out. In the place of A, I get 1 plus or minus. Here, what remains delta A upon A divided by B taken out. So, in the place of B, I get 1 plus or minus delta B upon B. Okay, this is what I get. Now, I am going to take this term to the numerator. Let's see what happens if you do so. Here I keep A as such, 1 plus or minus delta A upon A. And this term, when B is taken to the numerator, it becomes 1 upon B. And this term becomes 1 plus or minus delta B divided by B. And it gets reciprocal form. When it is taken to the numerator, we get power minus 1 to this. What is this? Let me explain this to you with the help of a simple example. If I have 1 upon x, then this can be written in terms of power as x power minus 1. Okay. The same thing I have done. It was given in denominator. When it is taken to numerator, we have to raise it to power of minus 1. The power of minus 1. Okay. Now, in the next step, what I will do? Here, I am going to multiply 1 upon B with the A. If I do so, I will get A upon B multiplied with 1 plus or minus delta A upon A is multiplied with 1 plus or minus delta B upon B, and here power is minus 1. Okay, and we know here A upon B is nothing but Z. Okay, in the place of this I can use Z. Let's do it. Z plus or minus delta Z equals to Z multiplied with 1 plus or minus delta A upon A, and this term 1 plus or minus delta B upon B, power minus 1. Now see what I do. I am going to apply binomial theorem. Then I am going to omit applying binomial theorem and omitting higher terms. So what I will get if I do so? Here, let me show this to you with the help of an example. Suppose I have 1 plus x power n. Then this can be written as 1 plus nx after the application of a binomial theorem to this. Okay, if you apply a binomial theorem and omit higher order terms, then you will get 1 plus nx for this kind of a function. Okay, now the same thing I will do here. I am going to apply this to this part of the equation. So what I will get at the end, that's z plus or minus delta z equals to z 1 plus delta a upon a. Yeah, minus 1 is multiplied with this part, so it will get 1 plus multiplied with minus becomes a minus, minus multiplied with minus becomes a plus, delta b upon b is kept here as such. Okay, now this equation is divided by z. What is divided by z? What I'll get? See? Z plus or minus delta z divided by z. The similar way, this side we divided by z. The remaining thing will remain as such. Yeah. Plus or minus. Okay. Delta a upon a. Here 1 minus or plus delta b upon b. Okay. This 2 get cancelled and you get 1 here. Okay, then I expand this part or expansion. I get z upon z plus or minus delta z upon z equals to 1 plus or minus delta a upon a will multiplied with 1 minus or plus delta b upon b. Okay. Now here is a plus or minus or plus. Both are almost same. So in the place of this, I will use plus or minus. Okay. So here this two get cancelled, and what we obtain is 1 here. So 1 plus or minus delta z upon z. Now I am going to multiply the terms present within this bracket with that of present here. So for that, 1 is multiplied with this part and also it is multiplied with this part. The next, I will multiply this part with this, and then this one is multiplied with this one. Okay, let's find out what we get next. By doing so, 1 multiplied with 1, we obtain 1. 1 is multiplied with this, I get plus or minus delta b upon b. Then delta a upon a, or multiplication with 1, get delta a upon a. The next I'm going to multiply these two. So what I'll get? Plus or minus delta A upon delta A multiplied with delta B upon delta B. Okay. Now here, delta A upon A is the fractional error involved in the measurement of quantity A, and delta B upon B is the fractional error or relative error involved in the measurement of quantity B. Here both are a small quantity, so it's almost neglected here. Very small quantity. By adding or subtracting this one to the remaining part is not going to make any big difference, so it is neglected here. So what I get here, one more thing I will do, I take this part to the left hand side. This plus 1 will become minus when it is taken to the other side. Okay, so what remains at the end is delta B divided by delta B divided by B plus or minus delta A divided by A. Okay, here I also have plus or minus, that I forgot to mention, and this part is neglected. Why do we neglect this? Let me explain this with the help of a simple example. Here delta A is a small quantity, a small part of A. When delta is divided by A, which is a large quantity, we obtain a very small value at the end as a result. So like we can say, suppose I have 1, I divide by 10, what I'll get 0.1. If I increase the value given in the denominator, then I'll get, suppose I increase it 10 times, then I'll get 100. 1 upon 100 is 0.01. Okay. In the place of 100, if I write 1000, I'll get 0.001. Like that, as I keep increasing the value given in the denominator, the result that I obtain is getting smaller. When I increase the value given in the denominator, the result obtained becomes smaller and smaller. So this is how this shows that when a small quantity is divided by a large quantity, the value obtained is very small. So by adding or subtracting that is small quantity is not going to make any big difference. It is like someone asked to measure the volume of water present in ocean. Okay, and someone removed 1 glass of water from ocean, and he wrote the volume of water present in ocean minus 1 glass of water. It seems to be a silly thing. No, removing 1 glass of water from ocean is not going to make a big difference. The same thing happens here as well. This inclusion of this part or omission of this part is not going to make a big difference to this part of the equation. So it is removed. Fine. Now we have come to the final part of this. Minus 1 plus 1 get cancelled, and what remains here is this, plus or minus delta Z upon Z equals to plus or minus is taken out as common. What I'll obtain, delta B upon B plus delta A upon A. This is what I obtain. Now this can be rearranged in this manner. Here both sides we have the same thing. So if you want to get removed, then what you obtain at the end is nothing but this, delta Z upon Z equals to delta A. Now I'm going to rearrange this, delta A upon A plus delta B upon B. Okay, this is the final expression. So I'm going to box this. This clearly shows that the total fractional error or the maximum fractional error involved in the division is equal to the sum of individual fractional error. the measurement of the quantities. Okay. Now we'll discuss the error in the power of a given quantity. Errors in the power of a quantity. Now I'm going to get the errors involved in the power of a given quantity. Let us consider A as a quantity. Then the measured value of A is taken as A plus or minus delta A, and I consider the power, the nth power of A as Z is equal to A power n. Okay, that way the error involved in the measurement of Z is nothing but Z plus or minus delta Z. Here is delta Z is the absolute error measured in the involved in the measurement of Z. Then A is written as A plus or minus delta A whole power n. Okay. Now I'll take a outside. When it is taken out, what comes out is nothing but A power n. Okay, because what is written here as A is actually A power n. So we get a 1 plus or minus. Here A is taken out. When A is taken out, now what remains here is nothing but 1. Why? How is it so? Here A can be written as 1 multiplied with the A. So when I take 1 A out, what remains is nothing but 1. That is why I have 1 here. Clear? Then here, when I take A out, I get delta A upon A over n. How is it so? Let me tell you. Here, I can write delta A as delta A multiplied with the A and divided by A. Okay. So when I take A outside, what remains is delta A upon A. This is what I have written here. Understand? Then according to this, A power n is nothing but Z. So in the place of A power n, I write Z. Understand? Multiplied with 1 plus or minus delta A upon A power n. Understand? Now this side, what do we have? Z plus or minus delta Z. Okay. Now I am going to divide this equation with the Z. With the Z. So what I'll get? I get this. Z plus or minus delta Z upon Z equals to Z upon Z 1 plus or minus delta A upon A power n. Okay. Now I am going to expand this portion of the equation. So Z upon Z plus or minus delta Z upon Z equals to Z divided by Z. We get 1. Okay. So this 1 is multiplied with this 1 plus or minus delta A upon A power n. Now look at it carefully what I am going to do. Here I will apply binomial theorem and I will omit higher order terms as I did in the previous case. Applying binomial theorem and omitting higher order terms. Okay, let's find out what we get if we do so. Here z divided by z is nothing but 1 plus or minus delta z upon z equals to, here if I multiply this part with 1, the value is not going to change. So I simply I'll leave it 1 plus or minus n is multiplied with this. So what I'll get, n multiplied delta a upon a. Whole term is taken within bracket. Got it? Now here I have 1, here I also have 1. I take this 1 this side. So plus 1 becomes minus 1 plus or minus delta z upon z. So what m is nothing but this plus or minus n multiplied with delta a upon a. Okay, here plus 1 and minus 1 get cancelled, and what you obtain is this plus or minus delta z upon z equals to plus or minus n multiplied with delta a upon a. Clear? Now if you want, we can omit this symbols as well. So at the end you get delta z upon z, which is n times delta a upon a. Clear? Now this shows that the maximum error involved in the nth power of a given quantity is nothing but the maximum fractional error, which is equal to n times the fractional error involved in the measurement of this individual quantity A. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.